Okay, now we're going to go over even and odd functions. Here I have a function, f of x is equal to x squared minus 3. Now I'm not going to tell you what even and odd is, but we're actually going to discover it pretty easily. In the table that you drew, somewhere in around the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there, is that the middle? I want you to write the number 0. And you'll see in a minute what I mean by even and odd. First of all, if I plug in 0, Daisy, if I plug in 0 into my function, what's my output value going to be? Negative 3. Now below this, I'm going to write the number 1. If I plug in a 1 into my function, Angel, what am I going to get?
Negative 2.
It's going to be all out on the video. Negative 2. Joel, if I plug in a 2 into my function, I'm going to get 1. If I plug in a 3, Cynthia, into my function, what am I going to get? 6. And if I plug in a 4, I'm going to get, Fernando, what am I going to get? 13. Now here's something interesting about the fact that this is a special function. If I plug in a negative 1 into this function, Jonathan, what am I going to get? Negative 2.
It just starts repeating itself?
If I plug in a negative 2, Alejandra, into my function, what am I going to get? 1. So, does anybody see a pattern as to what negative 3 and negative 4 are going to be? What are they going to be? 6 and 13. When you have a function where two opposite input values give you the same output value, we call that an even function. If two opposite output values give you equal output values, then the function is considered even, as long as the function does that for every single opposite input values. So if the function does it for all opposite input values, then it is considered even. You can tell by looking at the graph. If you look at a graph, you'll see that what's happening on the right side of the graph is very similar to what's happening on the left side. If you could just draw me a quick x-axis and y-axis on a parabola. It doesn't have to be too perfectly drawn. But looking at this parabola, if I look, for example, the input value 3 and the input value negative 3, I notice that they both have the exact same output. So therefore, that makes it an even function. If I look at positive 1 and negative 1, again, both output values are the same. That makes it an even function. Now in mathematically, we have to prove it like this. A function is even if you plug in two opposite numbers, like x and negative x, that they're equal to each other. So in this case, if I have f of x, that's just x squared minus 3. If I plug in negative x into here, that's going to be negative x squared minus 3. Does the left side equal the right side? Yes. Cynthia, how does that work out? And they don't look the same. This says x squared minus 3. This says negative x squared minus 3. They don't look the same.
When you square it, it's always positive.
They ain't gonna say it like that.
What are you saying, Tom?
X squared minus 3. Negative x, if I square it, I'm going to get a positive x squared minus 3. Left side equals right side. You have proven that this is an even function. So that is a proof so that it works for all possible numbers. Sure, we could try -1, +1, -2, +2, but you actually have to try every single number. So the way to prove it exactly, you try x and -x to see if they are equal to each other.
Wow.
Wow, amazing even functions.
Yan na me está haciendo útil.
Mister, you want me to tell you when 10 minutes are up?
It's okay.